All right, guys, section 5 is called solving rational equations. So just give you a little insight here. We're going to do section 5 today. And then the next class, we will start graphing rational functions. Next week gets a little interesting with early out days, shortened classes, and so on. So not exactly sure yet my plan there. But we do still have this section, one more. We'll review and take a test. So. All right, our objectives: to solve rational equations by cross-multiplying and solve rational equations by using the least common denominator. All right? Guys, when we have a fraction set equal to a fraction, I know I've talked about this, that is called a proportion. Okay? When we have a proportion, we can solve that by cross-multiplying. All right? So I can take whatever is, I'm going to take 3 times 4x plus 5. So 3 times 4x plus 5. And set that equal to x plus 1 times 9. I'm going to write that as 9 times x plus 1. And now we're just solving that equation. So I can distribute my 3 and distribute my 9. So I'm going to get 12x plus 15 equals 9x plus 9. Get all my x's on one side. I'm going to minus 9x on both sides. So 3x plus 15 equals 9. Minus 15 on both sides. I get 3x equals, what's that, negative 6. And then x equals negative 2. Guys, one thing that we need to make sure we do, we don't need to include any undefined values because we're really just finding, hey, what value of x makes this equation true? And that is negative 2. The only thing we need to check for is that this answer or answers that we get doesn't make our denominator 0. Okay? So for example, if I had x plus 2 in my denominator here, well, negative 2 makes that 0, doesn't it? So we would have to omit that, call it an extraneous solution, and in this case there'd be no real solutions. Okay? But since it doesn't make our denominator 0, x minus 2 is our answer. So when you're done here, just go up and just check, hey, is that going to make any denominator 0? If not, there's our answer. If so, then we'll have to admit it. Okay, same idea here. We're going to cross multiply. So I'm going to have 1 times that. So that's just really just going to be 11x plus 8. And then when I cross multiply this is going to give me x times 2x plus 5. All right, so if I distribute my x there, I'm going to get 2x squared plus 5x. And then on the left, I get 11x plus 8. Grace, what should we do from here? Okay, so we've got x squared and x, right? Guys, when we have x squared and x, what do we need to do? Great, set it equal to 0. Here we just had x's, so let's solve for x. Get all our x's on one side, all our numbers on the other. Here I have x squareds and x's, so I need to get everything equal to 0. So let's just, should I move everything to the left or to the right? To the right, because I like that, because 2 is already positive. So what's minus 8 and minus 11x? So that'll give me a 0 over there, and I'll get 2x squared. Oh, let's see, it's going to be, let me write it over here, minus 11x minus 8. So here I'm going to get minus 6x minus 8. I kind of like to have my 0 on the other side. Now what, Ralphie? Marv. 2 times -8, that's -16. Do we have factors of -16 that add up to -6? -8, -8, and +2. Okay, so I'm going to split this up. 2x squared minus, let's do +2x minus 8x minus 8 equals 0. Split it in half, factor by grouping. I can factor out a 2x, so I'm going to be left with x plus 1. What factors out here, Nicole? What kind of 8? Yeah, like -8, so I'm left with x plus 1. So my two factors, if I go, I'll just keep going here, I'm going to have 2x minus 8 and x plus 1. Guys, what do we recognize here? Take a 2 out, which means we should have shaken a 2 out here. Did anyone recognize that? I didn't either. Sometimes I just get so excited about marfing that I forget about it. But if we would have taken a 2 out of there instead of marfing, we would have been able to mini marf, which actually would have made our lives a lot easier. Okay, but that's fine. But we should probably take this 2 out now. So if I take a 2 out of here, I get x minus 4 and x plus 1. Again, that's equal to 0. So if I set both of those equal to 0, my x values are x equals -1 and x equals 4. Now, if I go back, are any of those going to make my denominator 0? No. So both of those are our solutions. Both of those values would make that a true statement. Does that make sense about me factoring a 2 out of here so we could mini marf instead of marfing? Okay, that's if we have a proportion. Just cross multiply. Now, if we don't have a proportion, we need to get a common denominator, because here I'm adding them, right? I'm adding them throughout. So, what's going to be our common denominator between x and 4? 4x. Our common denominator is just going to be 4x. So I need to multiply this by 4. So I better multiply that by 4. I need to multiply this by x. So I need to multiply the numerator by x. And if I do that by 4, then I need to multiply that by 4. So that's a 4. So I think I'm going to have 20 over 4x plus 7x over 4x equals 36 over 4x. How's my work look there? Did I make any mistakes? Now, I all have a common denominator throughout, right? Check this out. We're not going to do it this way all the time, but I want to do it this way just so you can see it. But remember, we have a rule that whatever you do to one side, we have to do to the other. And so I can multiply one side of the equation by any number I want, as long as I multiply the other side by that number. Okay? Now, if I multiply the left side by 4x, well, I have to then multiply the right side by 4x. What do I have to do to this 4x? Well, if I multiply 4x times both of these things, don't I need to technically distribute it? Okay, so if I had, I'm going to have 20 times 4x. Just watch this. I'm going to write it like this. And again, we're not going to do this every time, but I'm just writing to show you.
plus 7x times 4x over 4x. And then I need to do it on the right, where I'm going to have 36 times 4x over 4x.
What's going to happen, guys? Sadie?
Cancel out.
They're all going to go away. That 4x is going to be gone. That 4x is going to be gone. That 4x is going to be gone.
Okay, so next time we do a problem like this, as soon as I get common denominators throughout, I'm just going to cross them off, and I'm just worried about the numerators. Okay, because of this idea here.
So now I have 20 plus 7x equals 36.
I think we can solve that equation, can't we?
Minus 20 on both sides. I get 7x equals 16. Divide both sides by 7. X is going to equal 16 sevenths.
Kind of seems like a weird answer. And unless we find a mistake somewhere there, we're just going to go with that. Questions there? Again, we're not going to do this, though, just because we know that. So if I look over here,
Again, 1 is like 1 over 1.
so I need a common denominator between 1, x minus 5, and x. What's that going to be?
Now, can I just minus 5 from here and just call it x minus 5?
Can't do that, can we?
So our common denominator here is actually going to be x times x minus 5.
Okay.
So what do I need to do to this to get my common denominator to be that? Well, I better multiply by both, right? So x times x minus 5 times x minus 5.
What do I need to multiply the second one by, Naya? Not 1.
Oh, X.
I need an x.
Alyssa, what do I need to multiply this third one by?
Great, x minus 5.
I personally think the hardest thing about this is kind of staying organized from this step to go to the next one.
Okay, so, but if I look at this, I'm going to have x times x minus 5 over x times x minus 5 minus 8x over x times x minus 5 equals 3 times x minus 5 over x times x minus 5.
Every single denominator is the same, isn't it? So if we wanted to, we could multiply everything by x times x minus 5, but I think it's a lot easier, really, if we just do one of those deals. So now I'm going to have x times x minus 5 minus, don't forget the sign, 8x equals 3 times x minus 5. So if I distribute this here, I'm going to get x squared minus 5x minus 8x equals 3x minus 15. I have an x squared in x's.
Well, let's combine like terms first. I get x squared minus 13x. If I equals 3x minus 15. I then need to get everything equal to 0. So I'm going to minus 3x on both sides. And I'm going to add 15. So I get x squared minus 16x plus 15 equals 0.
We need a mini marf. Is this marfable? Factors of 15 that add up to negative 16. Oh, -1, -15. Guys, I'll just let you know, if this doesn't factor, what should we do? Quadratic formula.
Absolutely. But it does. So we get x minus 1 and minus 15 equals 0. So then my two x values are going to be 1 and positive 15. Before we call that good and move on, we should probably just check to make sure they won't make any of my denominators 0, which they won't. So there we go.
Any questions about these two that we just did? Okay, we'll do two more and then we'll do the back side.
Okay, so again, this 5 is over 1.
So a common denominator. Well, geez Louise, x minus 1. What do we do with that guy? Ask yourself, does it factor? Difference of squares.
So 7 times x minus 1 minus 5 over 1 equals 6 over x squared minus 1 is really x plus 1, x minus 1.
Okay, and now I need to get a common denominator.
Well, I think our common denominator is going to be this. So I better multiply this by x plus 1, top and bottom. And I need to multiply this by both of those. So x, I'm just going to erase my 1. It's going to be x plus 1, x minus 1, x plus 1, x minus 1.
Now, if we notice, all of our denominators are the same. So if you don't want to write it all out, then we can just write out the numerators. Just be careful that we are including everything. So I'm just going to scratch off the denominators now. So I'm left with 7 times x plus 1 plus 5 times x plus 1, x minus 1 equals 6. Good. I did that on purpose. Should be a minus there, right?
Yeah.
I see that more often than not. Just get in a hurry and just drop that sign. All right, and now we're just solving this guy. So I can distribute my 7 and get 7x plus 1. Oh yeah, plus 7. I did not do that on purpose. And now, how do you guys want to do this one? You want to distribute the -5 first or FOIL? Now, we had x squared minus 1, right? And we factored it to be x squared plus 1, x squared minus 1. So when I FOIL those, x squared minus 1, right? Let's use our resources there. So here I'm going to get -5 times x squared minus 1. Now, if you wanted to put that all together, you could have. I like to write it all out. So I get 7x plus 7, and now we're distributing the -5. So -5x squared plus 5 equals 6. Again, I got x squareds and x. Let's get everything to one side. Is that going to be the right or the left? I like right. So this 5x squared could be the same. Now let's combine like terms first. 7x. Actually, I'll do this. Ooh. I'm going to say -5x squared plus 7x plus 12 equals 6. Now I'm going to move everything to the right. Now, guys, if you wanted to, it's a lot easier to move everything to the left, isn't it? So if you wanted to do that and just -6,
and then flip all of the signs, that's the same thing. So I get negative 5x squared plus 7x plus 6 equals 0. And now if I wanted to go through and switch all of my signs, that's the same thing as moving everything to the right. Because this, I just don't like that negative sign there. So if I make that positive, I better make that negative and make that negative. Okay, so now we need to MARF. There's not a GCF there, so I should say, okay, what are factors of negative 30 that add up to negative 7? What's that?
Negative 10 and positive.
I think negative 10 and positive 3 work. So now I break this guy up and say 5x squared. I'm going to say minus 10x plus 3x minus 6 equals 0. Split it in half, factor by grouping, factor out my 5x. So I'm going to be left with x minus 2. Factor out a 3, so I'm left with x minus 2. So I get 5x plus 3, x minus 2, and so x is going to equal positive 2, and what's this guy going to be? Negative 3/5. Check to make sure that the denominator is not 0 there. I think we're good. Okay, we need to do this last one. X squared minus 9, what does that factor to? Yep, so I'm going to have 6 times x minus 3 equals, kind of different, kind of backwards a little bit, but I'm going to have 8x squared, and then x plus 3, x minus 3, minus 4x times x plus 3. So our common denominator here, Mary Beth, what do you think?
X plus 3 times x minus 3.
Yep, x plus 3 times x minus 3. So I need to have an x minus 3 here and here. And I need to have an x, excuse me, that should be plus, right? Right?
Correct.
Correct? X minus 3, x minus 3. All my denominators are the same. I'm going to get rid of it. So here's going to be 6 x plus 18. I just distributed that. Equals 8x squared minus, when I distribute this, minus 4x minus 12x. Oh, 4x squared? Did I do that right? Yeah, because what am I distributing, guys? I'm distributing negative 4x. So when I distribute negative 4x times x, that's negative 4x squared. Negative 4x times negative 3 is positive 12x. That's kind of where we really start noticing it, that sign there. Tricky, tricky. So if I minus 6x on both sides, yeah, I guess we could have, couldn't we? So I'm going to get 0 on the left. Computer's lagging a little bit. Equals, so I'm going to minus minus 6x, and then minus 18. So I should combine like terms here between those two, and that gets me 4x squared minus 6x minus 18. Ooh, plus, thank you, plus 6x.
Is your GCF there? Take a what?
There's a 2 throughout, isn't there? So if I take a 2 out, I'm going to be left with 2x squared plus 3x minus 9. So now if I marf, 2 times negative 9 is negative 18. That adds up to 3.
Factors of negative 18 that add up to 3.
Negative 3, positive 6. So 2x squared minus 6x plus 3x. These are backwards, aren't they? Plus 6x minus 3x minus 9. Split it in half. Factor out a 2x. So 2x plus, 2x. And I'm left with x plus 3. Factor out a negative 3, so I'm left with x minus, or x plus 3. And then my two factors, if I go over here, are going to be 2x minus 3, x plus 3, and set those equal to 0. So x is going to equal 3 halves, and x equals negative 3. We go to check to see if they make any of them 0. Do any of these make our denominator 0? If I plug negative 3 in here, what do I get?
0.
Or if I plug in negative 3, what's negative 3 squared? 9 minus 9 is 0. So that needs to be omitted. That is not a solution. That's extraneous. This one does work.